The purpose of this video is to go over this exam review for the Advanced Functions course in detail, and we'll start with the multiple choice questions. The first one says the instantaneous rate of change of a function is, and D is the correct answer here. It's how quickly the dependent variable, we often call it y, but it doesn't have to be y, is changing with respect to a unit change in the independent variable at an instant or a point in a graph. So that's the definition of the instantaneous rate of change. An average rate of change is between two different points on a graph or points in time, not to be confused with the instantaneous rate of change. The domain of a function is defined to be the entire set of values of the independent variable. We often call it x, but again it doesn't have to be x, for which the function is defined. There can be restrictions on the domain of a function if there's places where the function is not defined for certain values. For question number 3, the range of a function is defined to be the entire set of function values of the dependent variable. We often again call it y, but it doesn't have to be. For number 4, which of the following is a polynomial function? And the correct answer here is B. Notice that B's equation has only positive integers or whole numbers as the exponents, x to the power of positive 3, x to the power of positive 2, x to the power of positive 1. The negative 11 is just a constant here. Now the coefficients could be a fraction, that's okay, like the 3/4, but that is a polynomial function. This is actually a trig function because of the cosine. This is a logarithmic function because of the log base 2. And this is called a rational function because it's, now the 5x minus 4 is actually a polynomial, but it's 3, a number, over a polynomial function, so that makes that a rational function. For number 5, the blank row of differences for quartic. A quartic is a 4th degree polynomial. Functions are all the same. And it's the fourth, since it's a quartic, a 4th degree, the 4th row of differences would be the same for a quartic function. So D is the correct answer for 5. For number 6, even functions have which of the following characteristics? And A is the correct answer here. Their even functions are symmetrical about the y-axis. And so if you evaluate the function at a negative x value, you get exactly the same as if you evaluate it at the positive counterpart to that, f of x. So f of negative x equals f of x. This is the definition of, or the description of, an odd function, if f of negative x equals negative f of x. And this really doesn't have much to do with even or odd at all. For number 7, the remainder theorem states that when a polynomial p of x, we'll call it, is divided by x minus b, the remainder is the polynomial evaluated at this number b. That's the remainder theorem. I've actually put here for B is actually the factor theorem. If that p of b value is 0, then x minus b would be a factor of the polynomial. So that's actually the remainder theorem, the factor theorem in B. So A is the correct answer for number 7. Again, here number 8, we have the factor theorem states that if p of b equals 0, then x minus b is a factor of the polynomial. So the factor theorem is just saying that if you get a 0 for your remainder, that's what p of b equals 0 means, then x minus b would be a factor. Just like when you divide 12 by 3, you get 4, remainder of 0, so 3 is a factor of 12. For question number 9, what is the domain of this function? The domain is the entire set of real numbers for a rational function, except there can be some restrictions. There can be values that make the denominator have a value of 0, and you can't divide by 0, so that would make the h of x value undefined. And so we would get those by solving. We would set the 7x plus 14. So that cannot equal 0. Because if it equals 0, you're dividing by 0, and the h of x value would be undefined. So if we solve for x here, bring the 14 over, so we would get 7x equals negative 14, and then divide out the 7. I should have not equal to here. So x cannot equal negative 2. And so that's why C is the correct answer here. The domain is the entire set of real numbers with the restriction that x can't be negative 2, because negative 2 is the one value that makes a 0 in the denominator, and hence the function undefined. Flipping on to question number 10, what is the horizontal asymptote for this function? And notice that in this rational function, the power of x in the numerator is the same as the power of x in the denominator. And so I refer to those as the dominant terms, and it's x the first on top and x the first on bottom. So to get the horizontal asymptote, what we do is it's actually the limit of this function as x tends towards infinity. But basically, it's the ratio of the dominant term in the numerator divided by the dominant term in the denominator. See, basically, the negative 3 becomes insignificant when x becomes large. And so 10x divided by 2x, the x's divide out, and 10 divided by 2 gives you 5. And so the horizontal asymptote would be y equals 5. And so that's why A is the correct answer for number 10 here. To get the vertical asymptote for this, the vertical asymptote is really the same as that restriction from question number 9. And so the vertical asymptote, we would set you're basically looking for the restrictions. So you set the denominator equal to 0, and so you bring that 3 over, so 2x would equal 3, and after you divide out the 2, you get x equals 3/2. So 3/2 is the restriction for the domain, so it's the vertical asymptote. And so that's why B is the correct answer for number 11. On to some trigonometry now in the next several questions. And this is really SOHCAHTOA, or the definition of sine, cos, tan, etc., all those. Sine is defined to be opposite over hypotenuse, so B is the correct answer for number 12. Cosine is adjacent over hypotenuse, which is D here. Now, cosecant is the reciprocal of sine. So if sine is opposite over hypotenuse, then cosecant would be hypotenuse over opposite, which is the C answer here. Tan, if you remember from SOHCAHTOA, the TOA in the middle, SOHCAHTOA, or sorry, on the end, I guess it is. So tan is opposite over adjacent. So that's the answer for number 15, which is A. Secant is the reciprocal cosine. Now, cosine was adjacent over hypotenuse, so the secant would be hypotenuse over adjacent, which is the answer D here. And cotan is the reciprocal of tan. Now remember, tan is opposite over adjacent, so cotan would be adjacent over opposite. So 17, the answer would be E. For question number 18 here, we're asked to find the tan of 7 pi over 6. And I'm going to bring up something called the unit circle. These are the special angles in the unit circle for all the special angles between 0 and 2 pi. Now, if you look at the top here, it says cos theta, sine theta. The x-coordinate is the cosine of the angle of rotation, and the y-coordinate is always the sine. So, for example, for the pi over 6 angle, that's rotated from here up to this point, the cosine of pi over 6 would be exactly root 3 over 2, and the sine of pi over 6 would be exactly 1/2. Now, to find the tan of pi over 6, the tan isn't explicitly on this, but tan is defined to be sine over cosine. That's one way you can evaluate tan. And so, to find the tan of 7 pi over 6, we would find the sine of 7 pi over 6 and divided by the cosine of 7 pi over 6. So 7 pi over 6 is this angle here. So the sine is the negative 1/2. So we would have negative 1/2 in the numerator. And the cosine is the negative root 3 over 2. Now we're dividing two negatives, so the answer is going to be positive, so I'll drop the two negatives. We divide rational expressions by taking the numerator, the top one, and by multiplying by the reciprocal of the denominator, so 2 over root 3. Now these 2's divide out, so we get 1 over root 3. So that's the exact value for the tan of 7 pi over 6. That's why A is the correct answer for number 18. Let's move it down a little bit here for number 19. Now for number 19, and we'll move this down just a little bit too. For number 19, the cosecant of 4 pi over 3, cosecant is the reciprocal of sine. So this is actually 1 over the sine of 4 pi over 3? So we'll look on the unit circle and find 4 pi over 3, which is this angle here, and the sine is this negative root 3 over 2. Maybe I'll move it down a little bit more. So the sine is negative root 3 over 2, so we would have negative root 3 over 2 in the denominator here. And so this basically says take the reciprocal of this, so the reciprocal will be negative 2 over root 3, which is answer E for number 19. And we'll move this down a little bit more to do number 20. Okay, so for number 20, and I think I need even more room here. Go down a little bit more. There we go. So cotan. Now cotan, you can actually do the reciprocal of tan, but cotan is also equal to cosine over sine, just like tan was sine over cosine. So if we find the cos of 3 pi over 2, the angle, and divide that by the sine of 3 pi over 2. So the 3 pi over 2 angle is right here. The sine is negative 1, the cos is 0. So it would be 0 divided by negative 1, which of course is 0. So that's why D is the correct answer for number 20. Okay, let's get rid of this unit circle here. So for question number 21, to convert from degrees to radians, we multiply by pi over 180. One of the ways I remember it is, you see, if you want to go into radians, then you need the pi in the numerator. So your answer is in terms of pi, because generally exact angles in radians, you have a pi in them. Okay, and the degrees must divide out. So for example, if you were converting, let's say, 120 degrees into radians, when you multiply by the pi over 180, see the degrees divide out because one's on top, one's in the denominator. And so we would go 60 degrees goes into that twice, and 60 degrees goes into that 3 times. So the answer is 2 pi over 3 radians. So that's why D is the correct answer. We multiply by pi over 180 degrees to convert into radians. For number 22, cosecant, and up here is the reciprocal of sine. That's what I used actually, number 19. So cosecant is 1 over sine. Cosecant theta is 1 over sine theta. Secant is reciprocal cosine, so secant is 1 over cos theta. Secant theta is 1 over cos theta. And cotan is the reciprocal of tan, so cotan theta is 1 over tan theta. There isn't a cos theta over sine theta answer here, but that would be correct as well. These 3 questions are really talking about the reciprocal relations more than anything else. Which of the following is equivalent to the sine of negative 5 pi over 6? And I think we need the unit circle back here. And maybe we'll leave it up there. That's a good place for it. So, well, first of all, what exactly is the sine of negative 5 pi over 6? Well, negative 5 pi over 6 is just the opposite rotation to 5 pi over 6. So, you see, 5 pi over 6 is right there. So, a positive rotation would rotate around to this point. So, the negative rotation of the same amount would rotate us around to that point right there. And we're looking for the sine, so the sine would be negative 1/2. So that's equal to negative 1/2. So basically what we can do is find out, well, which of these is negative 1/2. So the sine of negative 3 pi over 4. Well, you see 3 pi over 4 would rotate to here, so a negative 3 pi over 4 would rotate to that point there, the same amount but a negative rotation. So the sine of that is negative root 2 over 2, so that's not the same. Tan is 7 pi over 2. Well, 7 pi over 2 is actually more than a full rotation. So this is pi over 2. You could think of pi as 2 pi over 2, 3 pi over 2, 4 pi over 2. This would be 5 pi over 2, 6 pi over 2, and so 7 pi over 2. And so we're looking for the tan. Now, the tan is the sine over the cosine, so we divide negative 1 by 0. It's actually undefined, so it certainly isn't equal to negative 1/2. The sine of 5 pi over 6, well, that's just a positive rotation. 5 pi over 6 rotates us to here. Notice that's exactly the same place, and, well, almost the same place. It's the same as the positive rotation. So that one is actually positive a half. So same amount except the opposite sign. So C is not the correct answer either. The cosine of 15 pi over 4. Well, if you think of the unit circle in terms of pi over 4, this is pi over 4. That would be 2 pi over 4. That's why this one's 3 pi over 4. 4 pi over 4, 5 pi over 4, 6, 7. That would be 8 pi over 4. Keep on going. 9, 10, 11, 12, 13, 14, 15 pi over 4 actually takes us to here. So it's a full revolution and then almost another full one. So we're looking at this point right here. The cosine is root 2 over 2, so that's certainly not the same as negative a half. The cosine of 4 pi over 3, E is actually the correct answer here after working through all those. 4 pi over 3 actually rotates us right down to here. And the cosine is negative a half. So that is the same as the sine of negative 5 pi over 6. So E is the correct answer for 25. For question number 26, it says using the diagram at the right, find the secant of angle beta. Well, secant is the reciprocal of cosine. So in order to find the secant, let's see here. Cosine is adjacent over hypotenuse, so this would actually be hypotenuse over adjacent. And we do actually have the adjacent, that's the 11. But we don't have the hypotenuse. This would be the hypotenuse up here. So we need to use Pythagoras Theorem to find the hypotenuse. The hypotenuse value squared is equal to 5 squared plus 11 squared. So basically it's the root of 5 squared plus 11 squared. So 5 squared is 25. (11 squared is 121. And if you add 25 and 121, you get 146. So it's the root of 146. So the hypotenuse, so we would have the secant of angle beta. It's the hypotenuse, which is the root of 146 over the adjacent side, which is the 11. And so that's why B is the correct answer for number 26. Moving on to question number 27. For question number 27, we need this trig identity because this is the sine of the difference of two angles, and of course if it was a sum we could use the very similar one. So it's the sine of a minus b, pi over 2 minus x, and we also need, I kind of hit the unit circle down here too, we need that as well. And so notice for a plus b, there's a plus in the middle. For a minus b, there's a minus. So this is basically going to be, and I'll actually write up here a little bit higher, it'll be the sine of pi over 2 cos x minus the cos of pi over 2 sine x. Well, what's the sine of pi over 2? The sine of pi over 2 is 1. So basically, this is 1 times the cosine of x minus, and the cos of pi over 2 is 0. So by its times 0 times the sine of x. Now 0 times the sine of x, of course, is 0. So basically, this just simplifies to cos x. So that's why B is the correct answer for number 27. Now, we need a different trig identity for number 28 here. So the identity we need for number 28 here is the tan A plus B1. So notice that the plus or minus is the same here as is on top, but it's opposite in the bottom. So when we write this out, it would actually be the tan of the A angle, which is the pi over 2, plus the tan of x over, and then be 1, oh, sorry, I put the wrong sign on top. It's a minus here, so this actually should be a minus, so let me fix that. And so notice it's the opposite, plus or minus, minus or plus. So we're doing the minus, so there should be a plus in the bottom here. Plus, and then the tan of pi over 2, tan x. So the tan of pi over 2 is it's sine over cosine, so it's 1 divided by 0. So notice that since the tan of pi over 2 is undefined, you can't divide by 1 by 0, you can't actually use this identity to calculate this. You would have to know, and if you did many tans and cotans of angles, that the tan of pi over 2 minus any angle is the same as the cotan of the angle. So C is the correct answer for number 28. And there are identities for that as well. For number 29, it says determine the equation of the function pictured at the right. And so notice that it starts at the origin. So to me, it looks like a sine function. But if you want to use a cos function, you could actually just have a phase shift. But you can do the sine without any phase shift. This is the axis for the function, and it goes up to a maximum of 4 or down to negative 4. So the amplitude is 4. The period is actually a 4 pi. So you'd have to have like a half here, because in order for the period to be 4 pi, if you take 2 pi and divide it by the half there, that's the same as 2 pi times the reciprocal of a half, and so that's how you get a period of 4 pi. You'd need a half in front of the x here. So D is actually the correct answer. Amplitude of 4 be sine a half x, because it's a sine function and the period works out to be 4 pi. For question number 30, it says determine the equation of this function pictured here. And so notice the axis is down here at negative 1, so there should be a minus 1, which actually restricts your two possible answers to either B or C, possibly. It couldn't be A, couldn't be D, or I guess E as well. There's 3 different negative 1s there. And so the amplitude would be 5, because it's going from negative 1 to 4, or negative 1 down to negative 6. So the amplitude is 5, so D can't again be right. Pi over 2 is 3 blocks. So if we take, notice I'm thinking about the phase shift here right now. The phase shift is actually sort of looks like 1 block to the left. So if you take pi over 2, since that's 3 blocks, and divide it by 3, then that's how big one of those blocks would be. So if you take pi over 2 and multiply by the reciprocal of 3, which is the third, you get pi over 6. So there's a pi over 6 phase shift to the left. So notice that C and B both have a phase shift of pi over 6 to the left. So are we using cosine or are we using sine? And actually notice the difference of 2 here. The period here is actually fairly short. It's actually just 1, 2, 3, 4 blocks. So, well, how big is 4 blocks? Well, if you take that, see, 1 block is pi over 6. So if you take pi over 6 and multiply it by 4, you get 4 pi over 6, which is 2 pi over 3. And I just did notice this is actually not 4 blocks, it's actually 3. 1, 2, 3. So my mistake there in determining the period. So let's fix that. So 3 pi over 6, which simplifies to pi over 2. So that's the length of the period. So if you want the k value, like what goes in front of like 2 or a half or a 4 here, I mean, here it says E is the correct answer, so it should be a 4. The k value is 2 pi, like the standard 2 pi for the sine or cos function, divided by the pi over 2, what the actual period is. So if we take 2 pi and multiply by reciprocal pi over 2, 2 over pi, the pi's divide out, so 2 times 2 is 4. So that's why the k value is 4 here. Now, it looked like if we were using sine, the phase shift would be pi over 6 to the left, but we're actually using cosine here. So notice that the cosine function actually doesn't have a phase shift at all. It starts at a maximum here. And we've got the right period because k is 4, and it's been translated down 1. So like it is possible to make a sine function for this. And in fact, for this one here, if we had a 4 here instead of a 2, that would have the right amplitude, the right period then. It's translated pi over 6 to the left and 1 down. So if that was a 4, then B could also be a right answer for number 30. For question number 31, negative sine x, and this is actually another identity. We actually could use the cosine pi over 2 plus x plus, or a plus b one for this one. And so let's do that. Okay, so I just brought that identity just to demonstrate that D is the correct answer here. And so it's the cosine of pi over 2 minus x. So A is the pi over 2 and B is the x angle. So if we're doing this, just write this out, plus x. So that would be the cosine of the pi over 2 angle times the cosine of the x angle. And A plus B is plus or minus here, minus or plus here, so the opposite sign. So we have a plus, we want a minus before the two signs. So sine pi over 2 sine x. Well, what's the cosine of pi over 2? Cosine of pi over 2 is 0. So basically, this is 0 times the cosine of x minus, now the sine is negative 1. The sine is 1, sorry. The negative comes from this negative here. So the sine of pi over 2 is this 1 here. So it's minus 1 times the sine of x, which equals negative sine x. So negative sine x is equal to cosine of pi over 2 plus x. So that's why D is the correct answer for number 31. And flipping on to number 3 here, the graph at the right is, and this is the graph of the cotan function. Well, how would I know that? Notice where the vertical asymptotes are. They're at pi, 2 pi. And if to remember which one this is, because like tan and cotan kind of look a lot alike. Cotan is cosine over sine. And so notice the denominator is the sine function. So vertical asymptotes occur where the denominator is 0. Now the denominator here, the sine x, is equal to 0 at all multiples of pi. So pi, 2 pi, 3 pi, negative pi. And so that's where all the vertical asymptotes are. So that is a way I could determine that this is the cotan function. Number 33, what's the amplitude of this function? Amplitude is the, the absolute value of the number up front. If that happened to be a negative, we would still say the amplitude is positive. So the amplitude would be 3 here. The amplitude of this, now there's a negative here, so we discard the negative. So otherwise there's a 1 here. It's actually negative 1 in front of the sign. So the amplitude would be D, 1, not negative 1. To get the period for number 35 here, we would divide 2 pi by the 5. And so that's why B is the correct answer for number 35. For question number 36, the graph shown is, and this is an exponential graph. And actually, we've got lots of exponential graphs. You remember the ones that have a base between 0 and 1, like a quarter or a third, are the ones that go in this direction. So D or E could not be the correct one for this graph. So is it 2 to the x, 3 to the x, 4 to the x? Well, if you identify a point on the curve, notice that, for example, this point right here is the point 2, 9. So which, and I can take other points too, that's actually on B here, because if we put a 2 in place of x, we would be evaluating 3 squared, which equals that 9. So that's how I could tell that for 36 the answer is B. It's 3 to the power of x function. Now, so this is one of the ones that has the base is a fraction between 0 and 1. It's a decreasing function. And again, I'll identify a point on the curve. So, for example, I see this point right here is the point negative 2, 4. Negative 2, comma 4. And that says C is the correct answer, so I'll show it C is the right one. So if we put negative 2 in place of x here, we would have a half to the power of negative 2. Now, remember the negative means the reciprocal, so this is actually the same as the reciprocal of a half squared. So it would equal, the reciprocal of a half, of course, is 2 raised to the power of 2, which equals 4. And so that's the correct point on that. So C is the correct one for 37. For number 38, it says write h equals 3 to the p in its equivalent logarithmic form. And the logarithmic form says the exponent, which is the p in this case, would equal the logarithm of this base 3. If I want to check the log form and see which one of these is equivalent to this exponential form, I kind of always do it like this. The base here, this raised to the power of p, should equal that, which is exactly what h equals 3 to p says. 3 raised to the power of p is equal to h. So that's why A is the correct answer for 38. For question 39, it says write log base A of b equals c in its equivalent exponential form. So it'd be A raised to the power of c would equal b, which is question answer B here. And for number 40, you're asked to simplify this into one single logarithm instead of sum and difference of 3 different ones. And so maybe we'll move down here a little bit and make a little bit of room to write this out. And let's do this kind of official here. Okay, so we're evaluating this. So the first thing that I would do is bring this 1/3 up as a power of the x squared, and the same with the negative 2, power of y, and the 8, whoops, I'm grabbing hold of that, and the 8 is a power of z. So I would then rewrite it as it's the logarithm base 2 of x squared. Now to the power of a third is the same as the root. I probably should write that as a root. Notice the cube root written here. So actually let's simplify that, because all my answers are written in that form. And I'm just going to move this down a little bit so I have a little bit more room here. So the cube root of that x squared, and then minus, so when I bring this 2 up here, logarithm base 2 of y squared, and the 8 up is the power of z, so plus the logarithm base 2 of z to the 8th. Now those are all logarithm base 2, so that's how I can write as a logarithm, one single logarithm. So it's logarithm base 2. Now, the ones that are added, so this and the plus log base 2 of z to the 8th, those are added together. So I can write that as one single logarithm as the cube root of x squared times the z to the 8th. Now, this one's subtracted here. So the difference rule says that we would write this over the y squared. And we really should have brackets on all this like this. And so notice that that is answer B here. The logarithm base 2 of the cube root of x squared, z to the 8th, and then over the y squared. So that's why B is the correct answer for number 40.